Chapter 11-5, volumes of pyramids and cones. All right, so the volume of a pyramid is 1/3 the product of the area of the base and the height of the pyramid. All right, so this right here, V equals 1/3 times capital B times H is the formula. Capital B is the area of the base and H equals the height. So this equation right here is for the volume of a pyramid. So you can see in the diagram here, capital B refers to the area of the base. It's shaded in blue. And the height starts at the vertex. And it is the perpendicular distance from that vertex to the base. Notice it makes a right angle. So the height is perpendicular to the base. So notice even in the oblique pyramid, in which the pyramid is leaning to the side, the height is still this distance, the perpendicular distance to the base. So again, it starts at a vertex, and it is the distance that is the perpendicular distance to the base. So this part shaded in orange is still the base B, and the height runs outside the pyramid. In the case of the oblique pyramid, if it's leaning far enough, the height will be outside of the pyramid, but it's still perpendicular to the base. Problem 1, the entrance to the Louvre Museum in Paris, France is a square pyramid with a height of 21.64 meters. What is the approximate volume of the Louvre pyramid? Okay, so they just gave us a picture, not really a diagram, but they said that it was a square pyramid. We know that the base of the pyramid is a square. Okay, so if this side length right here is 35.4, then this side length right here is also going to be 35.4. Okay, so I'll just fill that in. And they gave us the height is 21.64. So if I were to draw in the height, I would just start at the vertex and just draw in the height. Okay, and the height is perpendicular to the base. It's a little difficult to draw here, but assuming it's not oblique, the height will go right to the center of that square. And that's 21.64 meters. Okay, so that is the height H. So we said at the beginning the volume of a pyramid, I'll just write PYR, is going to be 1/3 capital B times H. All right, the base in this case is a square, and we know that the formula for the area of a square is just side times side, which equals S squared. All right, so each side length of the square base is S. All right, so back to the volume formula. 1/3 times capital B, which is going to be S squared, times H, the height of the pyramid. All right, so we have 1/3, and each side is 35.4, so that's going to be 35.4 squared, times the height H, which we said was 21.64. That was given in the problem. So the height H is 21.64. And all the units matched. They were all in meters. Okay, the side length and the height were both in meters. So we're good to go there. And I'm going to do this on the calculator. If you know how to do fractions, you can do 1/3. Or you can just multiply this out and divide by 3 at the end. All right, so I am going to do 35.4 squared times 21.64. Hit equals, and then divide by 3 at the end, and I get 9039.46. Okay, let's see, 9039.46. And meters got squared times meters, that's going to be meters cubed. All right, for the volume, the units are going to be cubed, or to the third power. So 9,039.46. And they got the same thing, but they rounded to the nearest whole number. All right, please try got it problem number 1. The sports arena is shaped like a pyramid, has a base area of about 300,000 feet squared, and the height is 321 feet. What is the approximate volume of the arena? Please try it. All right, so the volume for a pyramid is 1/3 base times height. So that's going to be 1/3 base. Capital B is the area of the base. They gave us the area is 300,000. So that's going to be 300,000. And multiplied by the height, that's 321. Now, when you do this, you have to make sure the units match. We have feet squared and feet. So we're good there. Okay. Once again, you can do the fraction, or you can multiply these and then divide by 3 at the end. All right, so I'll do it that way. 300,000 times 321 divided by 3. Click equals, and I get 321 and then 5 zeros. All right, so that's going to be 321 and then 1, 2, 3, 4, 5. So let's see. It's actually 32,100,000. The units were in feet, so for the volume, that is going to be feet cubed, because we did feet squared times feet, so that's feet cubed. Okay, once again, for volume, the units are going to be cubed, or to the third power. All right, problem 2. What is the volume in cubic feet of a square pyramid with base edges 40 and slant height 25? All right, now they did say in the problem that it's a square pyramid. So if this pyramid base is a square and this side length is 40 feet, then this side length right here is also going to be 40 feet. Okay, and they gave us the slant height L is 25 feet. All right, and we said before the volume for the pyramid is 1/3 base times height. Okay, now did they give us the height? No, unfortunately we have to find this height. Okay, they gave us the slant height L, and we have to make a right triangle out of it. All right, so on the square pyramid, as long as it's not oblique, this goes right to the center of the square. So this side length right here on this right triangle that they constructed, since the whole side is 40, this side length right here is only going to be 1/2 of 40. Okay, so we know that half of 40, I'll do it down here, half of 40 is just 20. Okay, so this side length right here is just 20, and that's what they did on their triangle. This side length here is their slant height, and this is the height of the pyramid. Okay, so we need to use Pythagorean theorem to find h. All right, across from our right angle, that's your hypotenuse, that's OEC. The other two sides, I'll let them equal A and B. All right, so a squared, since a equals h, is going to be h squared. B squared is going to be 20 squared. And c squared is going to be 25 squared. All right, so we have h squared, and 20 squared is 400, and 25 squared is 625. Subtracting 400 from both sides. Bring down the h squared. 400 minus 400 cancels. Bring down the equals. 625 minus 400 is 225. Okay, solving for h, the opposite of squaring something is to take the square root. So square root of h squared is h. Square root of 225 is just 15. By the way, if you wanted to do this in one step, you can do 25 squared minus 20 squared, and then just take the square root of 25 squared minus 20 squared. All right, so the height right here equals 15. And now we're in business. Okay, they said a square pyramid. So the area for a square, we said it a minute ago, that's side times side, or s squared. All right, so that's the area of the base, capital B. So in place of capital B, I'm going to sub in s squared. So it's going to be 1/3 s squared h. Okay, s is the side length of the square base. So that's going to be 1/3. S squared is going to be 40 squared. And the height we calculated to be 15. Okay, so I'm going to do 40 squared times 15, and then divide by 3 at the end. 40 squared times 15 divided by 3, and I get 8,000. The units were in feet, so we did feet squared times feet. That's going to be feet cubed. Final answer. All right, please try got it problem number 2. What is the volume of a square pyramid with base edges 24 and a slant height equal to 13? All right, so I can't draw it too well, but the slant height is 13. So if you could draw that in, I would say that runs down the side of one of the triangles like so. And the slant height is 13. And the base edges are 24. And those are both in meters. Okay, so you have to use Pythagorean theorem and then do the volume of the pyramid, 1/3 capital B times h. If I could, I'll draw you the triangle real quick. If I were to draw the triangle here, it would be like this and this. Okay, the slant height is 13. And remember, if the base side length is 24, then this is going to be half of 24. And this right here is the height of the pyramid. So half of 24 is going to be 12. Okay, so solve for the height h and then solve for the base area, capital B. All right, so Pythagorean theorem, once again, go across from your right angle. And that, of course, is C. A and B, it doesn't matter, so I'll let A equal the height. I'll let B equal 12. So A squared is going to be h squared. B squared is going to be 12 squared. And C squared is going to be 13 squared. All right, solving for h squared, just do minus 12 squared on both sides. It cancels here. And solving for h, the opposite of squaring something is to take the square root. So I'll do the square root on both sides. This is going to be 169 minus 144. That's 25. The square root of 25 is just 5. Square root of h squared is just h. All right. So you can do this on the calculator if you can't do it in your head, but we're using 5 for the value of h. All right. So back to our volume formula. We have 1/3 base times height. Okay, we said the base is a square, and the area for a square is side times side, or s squared. So that's what we're going to use for capital B. All right, so this is going to be 1/3. Capital B is s squared. And h we just found a minute ago, that was 5. Or no, we'll just write h for now. All right, so s is the side length of the square base. That's 24. So we have 1/3. And the side length of the base is 24. That gets squared. The height we just found to be 5. Okay, I'll do 24 squared times 5 divided by 3 on the calculator. And I get 960. The units were matching. The units were meters for the slant height and meters for the base edges. So they did match. Meters squared times meters gives us meters cubed. So that is the volume of the pyramid.